right, last video from the first part of 5.4 is just showing you some applications of the derivative. There are types questions like this on Delta Math, which I really like because it continues to review old things in conjunction with the new. So this is a slope-based question. It wants the slope, which means I need to derive and put in an x value that's given. So you want to look at your function and see what rules are being played out here. This one is a quotient rule. So I'm going to do bottom times the derivative of the top. The derivative of the top is 2, minus top times the derivative of the bottom. So derivative of the exponent is 6x, and then the original e to the 3x squared, all over the bottom squared. So all over e to the 3x squared squared. I probably wouldn't take time to simplify this just because it's kind of messy to begin with, and I know I'm plugging a -1 in. So I'm going to do that now to get my slope. So when I put -1 into this first term, -1 squared is just 1, so I get 2e cubed minus, when I put -1 in here, it's actually going to change it to positive. And then I'm going to put -1 in here, so I'm going to have -6, and then I'm going to have e to the third. So I'm going to have 2e cubed minus 12e cubed, which is going to be -10e cubed, over, I'm going to get e cubed squared, which is e to the sixth. So it does take a little bit of exponent rule knowledge. You end up getting -10 over e cubed. And they actually do want you to write it in simplest form with no negative exponents. So that is your slope. When you do these, look for things like, what rule am I having to use in addition to e? Sometimes they're very basic ones. Sometimes you'll see a product rule or a quotient rule or a chain rule. And then when you're done deriving it, I would not spend a lot of time simplifying. Instead, I would take the x value that they give you, plug it into that derivative, and then try to clean it up as much as possible. They don't want really decimal answers, so try not to use your calculator really for much of anything, but they do want you to clean up the exponents. And then the other thing you're going to be asked, and these tended to be multiple choice, I noticed when I was going through and practicing some, is they want you to go a step further and do tangent line equations. So that's still looking at using slope. So this one, there's a couple different ways they're written. Some of them, they'll give you the function and the x value. You have to find the slope and the y-intercept. This one's actually a little different. This one is giving you the slope and wanting you to come up with the equation. So we know that, let's see, we know the derivative. So let's do that first. Let's start with taking the derivative because we know that is what incorporates with slope. So the derivative of -e to the -3x is going to be positive 3e to the -3x. The negative from out front cancels with the negative of the derivative. So we could write this as 3 over e to the 3x. We want to know when that equals 6 because that's what their slope are giving me. Again, sometimes they will give you an x value. If they give you an x value, you're going to plug that in to find slope. In this case, they're actually telling you what the slope equals. So if I cross multiply that, I'm going to get 3 equals 6e to the 3x. I'm going to divide by 6. So I get 1/2 equals e to the 3x. I'm going to take the natural log of both sides. Well, you know what? I'm going to multiply it by 2. Which way do I want to go about doing this? Yeah, I'll take the natural log of both sides. So I'm going to get the natural log of 1/2 equals 3x. Divide by 3. Divide by 3. So you'll notice all of them have natural log of 2, not natural log of 1/2. Here's what they did. They broke that natural log of 1/2 into the natural log of 1 minus the natural log of 2. Basically using a very simple logarithm property. The natural log of 1 is 0. So you end up getting an x value of negative natural log of 2 over 3. So it is negative, which means it's going to actually make it positive here when I do x minus the x value. So it's either the third or the fourth one. Finally, I'm going to take that x value and plug it into my original function to get my y value. So I'll do that up top. That's where I have room. So I have -e to the -3 times negative natural log of 2 over 3 minus 3. Well, let's see. The 3's cancel. The negatives cancel. The e and the natural log will cancel, which gives me just 2, and it has a minus sign in front, so I'm going to get minus 2 minus 3. So negative 2 minus 3 is negative 5. So that's my y value is negative 5. So my answer is this one. So sometimes the arithmetic, I think, is harder than the calculus with this. You're going to use the first derivative to find slope or to set it equal to slope if that's given. You're going to have your x value, plug that into your original function to get your y value. And in the end, they write all of them in point slope form, which is y minus y1 equals your slope times x minus x1. So then you're kind of filling in the blanks, filling in your y value, your x value, and your slope. And that shows you some of the extensions that you'll see with e's and derivatives.